to Unit 3, Lesson 4. So you're looking for the tasks to complete for U3L4. You can find it under assignments or on the weekly calendar by today's date, which is the 19th of November. As usual, we'll start off with a little breakout room discussion, pair and share, and we'll come back together to check in. Questions in the chat right now. If you were famous, what would you be famous for? Would you be a famous actor, famous singer, famous chef, famous writer, famous architect? I don't know. We'll come back together in 2 minutes. Go for it. All right, well, thanks a lot for sharing, everybody. Next on the docket is homework check. Things are looking good in that department. You had the climograph worksheet part 2, which hopefully, well, actually we didn't have that much class time to get to. Sorry, the class time we used on the graph, the local climograph and the reflection. So hopefully you got that done at least in class. And then the homework was just the this ed puzzle and the reading. Or sorry, not an ed puzzle, but the climograph, it's looking good. I'm seeing 12 attempts. Again, mostly free response, but of the answers, looks like we're pretty evenly distributed, which is great. And then there was the reading reflection on the most recent Hewitt chapters on wind, which we're going to review in a second. But again, answers to this are looking good. I'm seeing about 9 attempts on this. And Coriolis effect is something we're going to explore a little bit more today. So any questions or comments on the homework? Anything you got stuck on? Joseph?
Well, there's one problem in the quiz that I gave the right answer, but every time I do it, it's like it cancels it.
Okay. Might have been a mistake on my end then on the auto grading or something. So do you remember which question it was?
I remember, wait, let me go back to it real quick. Sorry.
Great. That's all right. You can throw it in the chat for me, and then I know then that I can go and check for it when we come back together. So cool. Okay. Did I see another hand go up? No. All right. So let's just quickly review key parts of the reading before I let you go for a couple activities. I'm just going to show you a short video here about the Dust Bowl. It's just over a minute long.
This fall on PBS, they had come to the far edge of the Great Plains in search of a new beginning, in the last place in America where a family could claim a homestead and build a future.
We had the best crop that we had had in 1929, and everything was looking up.
A sea of grass, once the domain of Indians and buffalo, disappeared beneath the blade of a plow.
I saw the whole country transformed in the sunset glow. All the brown prairie turned to gold.
But then, it was as if the land rejected them. The rains stopped, and the winds came.
We saw this cloud coming in, black, black dirt. And I'll never forget my grandmother, she said, "You kids run and get together, the end of the world's coming."
It came like a black wall, a tide of destruction that crashed over the broken plains, choking the life out of everything in its path.
You never really escaped the dust. It always found its way in, and that's, I think, what drove people crazy.
Some would pull up stakes and move on, but most stayed, always looking to the promise that next year would be better.
We were just too selfish, and we were trying to make money, and it didn't work out.
Ken Burns tells the story of a generation that was buried and what it took to dig out.
All right. How many people had heard about the Dust Bowl before? Most of you learn about it in history class, that kind of thing. Pretty crazy. Again, all due to wind erosion, right? And a little bit to a little bit due to greediness too, right? But the idea was that in the Great Plains in Central America, they just started farming like crazy, but they completely eradicated the natural plants and left all the topsoil loose in between plantings, and suddenly a drought hit, nothing grew, topsoil was loose, the wind kicked up, and then it literally carried all of this topsoil in the form of dust all over the world. Um, Everyone's seeing Dust Bowl in front of them right now. Just need some verbal confirmation.
Yeah.
Yep.
Yes.
I mean, it's mind-boggling to think about this giant cloud of dust moving towards you. And yeah, that led to, I mean, the drought in combination with that, with all the topsoil gone, even when the rains came back, they couldn't plant things very well. So it led to long-term famine, not a good situation, and something I think modern agriculture has learned from. One of the key points from the recent reading you did too is sources of wind, right? Why does the air on the surface of our planet actually move, right? There's nothing that's really pushing it or anything like that. And it's all due to molecular distribution. It's still this idea that things always move from areas of high concentration, where there's a lot of it, right, to areas of lower concentration. Air molecules want to move to where, from where it's really crowded, they don't like this, to where it's less crowded. And so that's what generates what we know of as wind. And the greater that difference in concentration, the more powerful it is. There was a question in the homework about students in a chemistry lab, right, that was venting out air. So a lot of chemistry labs have vents that are getting the air out of the room. That's going to lower pressure inside the classroom. So if a student were to suddenly open the door, air would come rushing in because there's less air inside, more air outside. Some of you might have experienced this in your own, moving in and out of buildings. Sometimes doors are harder to close or harder to open because of pressure differences between the inside and the outside. It's usually due to ventilation, air conditioning, that kind of thing. And being exposed to high winds in addition to low temperatures can be super, super dangerous, chiefly because of frostbite. I've got some diagrams of it down here, but it's exactly what it sounds like. It's basically when your skin freezes. We have a top layer of skin that's pretty much dead, so that's nothing that can be damaged or sloughed off, nothing to worry about. But you get to worse and worse stages once the living cells start to freeze, which means they can't get oxygen they need, which means they die. And so you get the frost nip, which is kind of like the redness. That can heal, though, relatively quickly. Superficial frostbites when you get these giant lumps of liquid that have been evacuated out of your cells. And then this is the bad stuff. It's the deep frostbite where things literally turn brown. That is necrosis. The tissue is literally dead. It's like you're rotting, but you're still alive. And so this is why if you're ever in an area with high winds and low temperatures, you need to cover up. This is why you see climbers on Mount Everest usually clothed head to toe. This is pretty straightforward. Our experience here in Pebble Beach is a lot of sea breezes. We tend to have a little warmer, lower temperatures, lower pressure inland towards Salinas, and so that brings a lot of air in off the Pacific, and that hits Pebble Beach and keeps this area very foggy and very temperate most of the time. That's what you call a sea breeze. Land breezes are the exact opposite, right? It's when, for whatever reason, there's lower pressure outside over the ocean, and so the wind cycles back out. And I'm sure some of you experienced both of these. I don't think they're necessarily always during, only sea breezes during the day, only land breezes at night. It varies obviously place to place, but is a good concept to know. And so that's what gives us these gyruses or gyri is what I usually say, where again, you have to just understand that warm air rises. So as it's, as air is towards the surface of our planet, it gets warmed up and it will rise from there. So warm air rises. And just as it does that, then it cools down, cold air falls. And so that creates these little cycles here that you see. And also kind of explains how, again, you have warmer air falling or cold air falling in the temperate zone, right? Keeping that area relatively temperate. It warms up as it approaches the equator. So that's where we tend to see very hot temperatures and rises up from there, right? Very low pressure, high temperatures right at the equator. Sailors are very aware of wind patterns on our planet, right? They know to like catch the westerlies or catch the northeast trade winds to get them to certain locations. Sailor always tried to avoid the doldrums, which is right on the equator where the two wind directions meet, and so it's kind of a dead zone, not somewhere you would want to get stuck or stalled in a ship. We're going to do an activity today to explore the Coriolis effect, which is all about perspective, right? It's basically the idea that if you are standing on something that is spinning, when you throw something straight, even though it travels straight, your perception of it, it looks like it is curving. So that's the key thing, is that the deflection of moving objects when they are viewed viewed from a rotating reference frame. So if you are moving and looking at something, you're not actually seeing this straight path that it's following. So they have kind of a confusing diagram here. Basically, you've got two people sitting on a little rotating wheel, and if it's not rotating, throw the ball to the other person, it travels straight. But if it is rotating, even though you throw the ball and it travels straight, still, that has not changed, right? In both these situations, that's the true path of the ball. But if this is spinning, your perception of it makes it look like it's actually curved in the way it's traveling. So you'll do a little drawing activity today to hopefully clarify this somewhat. And then there's ocean currents, which we'll spend a little bit more time on later. Kind of like wind, but not necessarily moving due to pressure differences. This is more temperature differences. And you can see, makes sense, right? We've got warmer waters towards the equator, colder waters in the more temperate and polar regions. It does explain a little bit about like the difference between coastal waters in the United States. So if you're ever on the southern coast, like in the Carolinas or something, the ocean water tends to be pretty warm because that water's coming up from the equator, right, and through the Caribbean. Whereas here in California, we have to wear wetsuits when you go surfing, right, because the water's relatively cold because it's coming from the north, right, from Alaska and that region. Now, you can see a lot more detail if you were to zoom in on this, and again, we'll touch on the ocean movements, but remember that ocean water also warms up the air. And so it makes sense that we see warmer waters where we also see warmer air temperatures, colder waters where we tend to see colder air temperatures. Any questions or comments on that? Okay, let me just take one moment to walk you through the activity you're going to do. We are now on step number 4 in the tasks to complete, simulating the Coriolis effect. As I said, you're going to be sort of drawing it. The way this is going to work, you're going to click on this assignment, simulating the Coriolis effect. It should take you to a quiz that looks like this. I have all the instructions and questions right here. So just read the instructions and scroll down, but essentially you're going to be drawing and cutting out an image of the northern hemisphere. Again, you don't have to draw every single detail, just kind of a rough outline of the main continents. Same thing in the southern hemisphere. And I'll walk you through how it's going to work, right? It's going to involve kind of spinning it and trying to draw a straight line, but it should, this is what you'll end up with if you're following directions correctly. And there's a couple reflection questions to then answer based on that. So I'll be here listening if you're not sure what equipment to use, or if you can't find something, or if you're not sure what to do, but all the instructions are there. I'm going to time for 25 minutes to complete the 2 drawings, upload your photo, and answer the questions. We'll check in after that time and move on from there. 25 minutes, let me know if you need help. Go for it.